remote reference layer in Java remote method invocation. Remote reference layer. The remote reference layer understands how to interpret and manage references made from clients to remote service objects. Here you can see another view of RMI architecture. As you can see here, the client makes a request of a remote object using client-side stub. The server object receive this request from the server-side object skeleton. Client initiate a remote method invocation by calling a method on the stub object. The stub maintains an internal reference to the remote object it represents and forward the method invocation request through the remote reference layer by marshalling the method argument into serialized form and asking remote reference layer to forward the method request and arguments to the appropriate remote object. Marshalling involves converting local objects into portable form so that they can be transmitted to a remote process. Each object is checked as it is marshaled and determine whether it implements java.rmi.remote interface. If it does, remote reference is used as it marshal data. If it is a remote object, the argument is serialized into bytes that are sent to the remote host and reconstructed the copy of the local object. If the argument is neither remote nor serializable, stub throws java.rmi.marshal exception back to the client. If marshalling of a remote argument succeed, the client-side remote reference layer received the remote reference and marshaled argument from the stub. This layer converts the client request into low-level RMI transport requests according to the type of remote object communication being used. In RMI, remote objects can potentially run under several different communication styles, such as point-to-point object references, replicated references, multi-thread, multi-class objects. Remote reference layer is responsible for knowing which communication style is in effect for given remote object and generating corresponding transport layer requests. In the current version of RMI, version 1.2 of Java 2, the only communication style provided out of the box is point-to-point object references. So this is the only style we here. For the point-to-point communication, the remote reference layer constructs a single network level request sent over the wire to the sole remote object that correspond to remote reference passed along with the request. On the server side, remote reference layer received the transport level request and convert it into the request for the server skeleton that matches the reference object. Skeleton converts the remote request to the appropriate method call of the actual server object, and which involves unmarshalling the method argument into the server environment and passing them to the server object. As you might expect, unmarshalling is the inverse process of marshalling the process to the client. Arguments sent as a remote reference are converted into the local stubs on the server, and arguments sent as serialized object are if converted into the local copies of the originals. If the method call generate a return value or an exception, skeleton marshals the object for transport back to the client and forward it through the server reference layer. This result is sent back to the appropriate transport protocol where it passes through the client reference layer and stub and is marshaled by the stub. Finally, handed back to the client thread that invokes the remote method. Here you can see the client process, client object, stubs, and remote reference manager is inside the client process. Here you can see server process, remote reference manager, skeleton, and server objects are inside server process. In client process, client objects interact with stub interacts with remote reference manager. Here remote reference manager interacts with skeleton interacts with server objects, and client process and server process. So server process is interacting, and RMI transport layer is between client process and server process. Here you can see the remote reference layer for remote manager, remote reference manager in server process, and for the client remote reference manager in client process with stub and skeleton layer. You can see the stub and skeleton here. Here you can see a overview of RMI interfaces and classes. The interfaces and classes that are responsible for specifying the remote remote behavior of RMI system are defined in the java.rmi package hierarchy. The following figure shows the relationship between several of these interfaces and classes. In RMI, this is java.rmi.remote interface. In RMI, the remote interface is an interface that declares a set of methods that may be invoked from a remote Java virtual machine. A remote interface must satisfy following requirements. A remote interface must at least extend either directly or indirectly an interface java.rmi.remote. Each method declaration in remote interface or its super interface must satisfy the requirement of a remote method declaration as follows. A remote method declaration must include the exception java.rmi.remote exception for one of its superclass, such as java.io exception or java.lang.exception in its throws clause, in addition to any application specific exceptions. Note that application specific exceptions do not have to extend java.rmi.remote exception. In a remote method declaration, a remote object declared as a parameter or return value, either declared directly in the parameter list or embedded within non-remote object in a parameter, must be declared as a remote interface, not implementation class of that interface. And the remote exception class. The java.rmi.remoteException class is the superclass of exception thrown by the RMI runtime during remote method invocation. To ensure the robustness of applications using RMI system, each remote method declared in a remote interface must specify java.rmi.remoteException or one of its superclass such as java.io.exception or java.lang.exception in its thrown clause. The exception java.rmi.remoteException is thrown when a remote method invocation fails for some reason. Some reason for remote method invocation failures includes communication failure, the remote server is unreachable or is refusing connections, the connection is closed by the server, failure during parameter or return value marshalling or unmarshalling, protocol errors, the class remote exception is checked exception, one that must be handled by the caller of a remote method is checked by the compiler, not runtime exception. Especially the remote object class and its subclasses with related to remote reference layer. RMI server functions provided by java.rmi.server.remoteObject and its subclasses java.rmi.server.remoteServer and java.rmi.server.unicastRemoteObject and java.rmi.activatable. The class java.rmi.server.remoteObject provides implementation for java.lang.object methods hashcode equals and toString that are sensible for remote objects. The methods needed to create remote objects and export them available to remote clients are provided by the class unicastRemoteObject and activatable. The subclass identify the semantics of the remote reference, for example whether the server is simple remote object or is an activatable remote object, that one that executes when invoked. The java.rmi.server.unicastRemoteObject class defined a singleton unicastRemoteObject whose references are valid only while the server process is alive. The class java.rmi.activation.activatable is an abstract class that defines an activatable remote object that starts executing when its remote methods are invoked and can shut itself down when necessary. Here you can see a remote implements remote object and remote object extends the remote object implements remote and remote server extends remote object and activatable extend remote server, unicast remote object extend remote server, remote exception extend IO exceptions. As an example, we can consider this one, and the remote reference layer defines and supports invocation semantics of RMI connection. This layer provides remote ref object that represent the link to the remote service implementation objects. Interface remote ref represent the handle for a remote object. A remote stub uses remote reference to carry out the remote method invocations to a remote object. And remote ref is in java.rmi.server package. As an exception example, we can consider this. If failed to initialize new remote call in deprecated method remote call, new method, new call, remote object option int long in interface remote ref. This is in package rmi java.rmi.activation. Sorry, this is in actually java.rmi.server package. As an example too, we can consider this one. The class unicast remote object used for exporting a remote object with JRMP and obtaining a stub that communicates to the remote object. Stubs are either generated at runtime using dynamic proxy objects, or they are generated statistically at build time, typically using RMIC tool. The method export object remote int exports the remote object to make it available to receive incoming calls using a particular supplied port. The object is exported with a server socket created using RMI socket factory class. The parameters obj the remote object to be exported, and port, the port to export the object on, and this is in package java.rmi.server. As an exception example too, we can consider remote exception. If export fails in method remote export object remote int in class unicast remote object. As an example 3, we can consider this one, creating an activatable object. The class activatable, the activatable class provides the support for remote objects that require persistent access over time and that can be activated by the system. And this is in package java.rmi.activation, and here you can see the code and implementing interface and the constructor, and here register object with the activation system, then export it to an anonymous port. As an exception example 3, now we are considering a remote ref interface in stub and skeleton interfaces. The remote reference is used to carry out remote calls on the remote object for which it is referenced. The interface remote ref, the remote ref represent the handle for remote object. The remote stub uses the remote reference to carry out the remote method invocation to a remote object. This is in the package java.rmi.server, which is in the module java.rmi. The interface remote ref represents the handle for a remote object. Each stub contains an instance of remote ref that contains a concrete representation of the reference. This remote reference is used to carry out remote calls on the remote object for which it is referenced. The invoke remote method object array and long method delegates the method invocation to a stubs object. remote reference and allows reference to take care of setting up the connection, the remote host, marshalling some representation of method and parameters, params, and the communication invocation to the remote host. This method either returns the result of the invocation on the remote object which resides on the remote host, or throws an remote exception if the call failed, or an application level exception if the remote invocation throws an exception. Note that the operation number opnum represents a hash of the method signature and may be used to encode the method for transmission. The method hash to be used for opnum parameter is a 64-bit long integer computed from the first two 32-bit values of the message digest of a particular byte stream using National Institute of Standards and Technology NIST secure hash algorithm SHA-1. This byte stream contains a string as if it was written using the java.io. Data output.write UTF method consisting of a remote method name followed by the its method description. For example, if a method of a remote interface has the following name and the signature, the string containing the remote method's name and descriptor would be following. The 60-bit hash value in the little Indian composition of a 8-byte sequence, where the first 4 bytes are the first 32-bit value of the message digest in a big Indian byte order, and last 4 bytes are the second 32-bit value of the message digest in the big Indian byte order. For example, the first two of 32-bit values of the message digest are OX BO B1 B2 B3 and OX BO B4 B5 B6 B7, and then the hash value would be OX B7 B6 B5 B4 B3 B2 B1 B0. Note this the method's new call remote object operation array and int long invoke remote call and done are deprecated as of Java 2 SDK Standard Edition version 1.2. The stub generated by RMC using the 1.2 stub protocol version do not use this method any longer. The sequence of the calls consisting of new call, invoke and done have been replaced by a new invoke method that makes a method object as one of its parameters. The method new call creates an appropriate call object for a new remote method invocation on the remote object obj. The operation array OP contains the available operations on the remote object. Contains available operation on the remote object. Operation number opnum is an index into the operation array which specified the particular operation for this remote call. The interface hash is a 64-bit value used to enforce compatibility between a stub and skeleton using the version 1.1 stub protocol. The interface hash is computed from the first two 32-bit values of the message digest of the particular byte stream using SHA-1. This byte stream contains the data as if it was written using the write int and write UTF methods in interface java.io data output consisting of the following items: int stub version number always 1 for each next pointer for each remote method in order in order of operation number. Next point, UTF-8 remote method name. Next point, UTF-8 remote method descriptor. Next point, for each declared exception in lexicographic order of binary name. Next point, UTF-8 the name of the exception class. The interface hash value is composed of the from the message digest in the same manner as described above, or for the method hash used in the invoke method. The invoke remote method remote call executes the remote call. Invoke will raise any user exception which should pass through and not be caused by the stub. If any exception is raised during the remote invocation, invoke should take care of cleaning up the connection before raising the user exception or remote exception. The method done allows the remote reference to clean up or reuse the connection. Done should only be called if the invoke call returns a successfully non-exceptional into the stub. The method getRef class returns the non-package qualified class name of the reference type to be serialized into stream out. The method remote hash code returns the hash code for the remote object. Two remote object stubs that refer to the same remote object will have the same hash code in order to support the remote object as keys of the hash table. The remote object forward a call to the hash code method to the remote hash code method of the remote reference. The method remote equals compares to remote object for equality. The two remote objects are equal if they refer to the same remote object. For example, two stubs are equal if they refer to the same remote object. Remote objects forward a call to its equals method and remote equals method of the remote reference. The method remote toString returns the string that represent the reference of this remote object. Now we are considering serverif interface. The interface serverif represents the server-side handle for the remote object implementation. The interface server is deprecated, no replacement. This interface is unused and is obsolete. The serverif represents the server-side handle for the remote object implementation. The method export object finds or creates a client stub object for the supplied remote object implementation OBJ. The parameter data contains information necessary to export the object, such as port number. The method getClientHost returns the host name of the current client. When calls from a thread actively handling a remote method invocation, the host name of the client invoking a call is returned. If a remote method call is not currently being service, then server not active exception is called. Now we are considering class unicastRef. The note there is a JDK internal dependency on the existence of these classes. GetLiveRef method, as it's inherited by unicastRef2 in the implementation of javax.management.remote.rmi controller. This is in the package sun.rmi.server. Now we are considering class unicastServerF. unicastServerF implements the remote reference layer server-side behavior for remote object exported with the unicast reference type. This is in the package sun.rmi.server. Now we are considering class liveref. Note this is a JDK internal dependency on the existence of this class and its get client socket factory method in the implementation of javax.management.remote.rmi connector. This is in the package sun.rmi.transport. Now we are considering properties that are useful to set on virtual machines VMs that export remote object in java.rmi properties. java.rmi.dgc.leastValue. The value of this property represents the least duration in milliseconds granted for other VMs that hold remote references to objects which have been exported by this VM. Clients usually renew a lease when it is 50% expired, so a very short value will increase the network traffic and risk late renewals in exchange for reduced latency in calls to unreferenced. The default value of this property is 600,000 milliseconds, 10 minutes. Now we are considering properties that are useful to set on VMs that export remote object in sun.rmi properties. sun.rmi.dgc.actTimeout. The value of this property represents the length of the time in milliseconds that server-side Java RMI runtime will strongly refer to a remote object or a reference to a remote object that has been returned from the current virtual machine as part of the result of the of a remote method call until it receives a positive acknowledgement from the client that the remote reference has been fully received or processed. This timeout only applies to a failure situation in which the client fails to send acknowledgement. Setting the value too low can increase the risk of a remote object being prematurely garbage collected when only the known reference to a remote object is the one in transit as part of the remote method call result. The maximum value is long.max value. The default value is 300,000 5 minutes. Now we are considering properties that are useful to set on VMs that make remote method calls. sun.rmi.dgc.client.gc interval. When it is necessary to ensure that DGC clean calls are unreachable, the remote references are delivered to timely fashion. The value of this property represents the maximum interval in milliseconds that the RMI runtime allow between garbage collection of a local heap. The default value is 3,600,000 milliseconds, 1 hour. Now we are considering Java RMI implementation logging. So system property name sun.rmi.server.log level, logger name sun.rmi.server.ref, information logged, server side remote reference, and also you can consider as another example we can sun.rmi.client.log level property, the logger name sun.rmi.client.ref, information logged, client side remote reference activity. Activation exception, the class activation exception, general exception used by the activation interface. This is in package java.rmi.activation. Now we are